Alright, so the polynomial we have right here is p of x equals x minus a1 to the nth power. And it goes on to x minus a to the infinity to the n to the infinitieth power. So basically what this is explaining is how the graph will function, how it will come out. If the exponent of n is odd, it'll come out like a shape like this or this, where the positive x coefficient will yield you going upwards and a negative x coefficient will yield you going downwards. If n is even, you'll get a graph more resembling this, where it bounces up and down or goes downward like this. Basically, if you have a negative x coefficient on this side, it'll go downward, and if you have a positive x coefficient, it'll go upwards. Now, if you go over here and look at these four rules, you can see pretty much the shape of any polynomial graph. So you have the odd positive graph right here, which is going, it's falling on the left side and going up and rising on the right side. And you know it's odd because it goes in two different directions on both sides of the graph. Right here you have the positive even polynomial graph, which rises on the left and rises on the right. And you know it's even because they've both gone the same direction. Down here you have the odd negative polynomial graph, which rises on the left and falls on the right. And once again, you know it is odd because it goes in two different directions. And down here you have the even negative, which falls in both directions. Yeah. So basically, how you know, another way of figuring out if it's positive or negative, you can test a to the nth. If it's less than 0, then it'll definitely be a negative. If it's greater than 0, it'll definitely be a positive. And that's basically how to explain this in the simplest of terms. So example 1, you have p of x equals x to the third plus 2x squared minus 8x. So we can tell it's going to be a positive odd graph because the n value is odd. So n equals 3, and obviously there's no coefficient there. So
it's 1.
It's 1, so it's positive 1.
Yeah.
So it's positive. So basically what we can do right here is we can factor out an x first and foremost. So you'll get the equation x equals x squared plus 2x minus 8. And then furthermore, we can get that into a more factored out form, which is x times x plus 4 times x minus 2. And that'll yield you your roots, which basically are 0, -4, and -2. And if you go over to the graph, you can plot those roots first and foremost. You have -4, 0, and 2. Now, we know the shape of the graph already because this tells us basically which way it's going to go. So we can already tell you that it's going to fall on the left side and rise on the right side. So that's where this line comes from. Now, if you want to find out exactly how tall, or the local minimum, the local maximum, or the local minimum, you can plot some x values in between the roots that will yield you y values. So if you plot, say, x equals 1, you'll end up getting -5, because if you take it out, you'll get 1 to the third plus 2, 1 squared, minus 8. So you get 1 plus 2 minus 8, -5. Now if you do the same for x minus 2, you'll end up getting -2 cubed plus 2 -2 squared minus 8 times -2. So you end up getting -8, a positive 8, and a positive 16. So these two cancel out, and you're left with 16. And that will give you your local maximum and your local minimum points. And that's pretty much how you solve and graph the entire polynomial equation.
The equation for the rational functions is r of x equals p of x over q of x. And two basic equations for this are y equals 1 over x and y equals -1 over x. This one, y equals 1 over x, is positive, so one curve is in the first quadrant and the other one is a reflection of this in the third quadrant. While for the negative one, it's also a reflection of this graph where the curve is in the second quadrant and the other curve is in the fourth quadrant. This equation y equals a plus 1 over x minus b is derived from this equation, which helps you find the horizontal asymptote and the vertical asymptote. This one then shifts the y-axis, and this one shifts the x-axis.
So we have our equation y equals 4 plus 1 over x plus 3, and we're going to find the vertical and horizontal asymptote. So going back to this form, the horizontal asymptote is a and the vertical asymptote is b, and we try to find it over here. Horizontal is 4 and vertical is -3, because -3 makes the form undefined. And then if we go over here to put down the asymptotes, it will show where our curves will not touch. And after that, we are going to, so we're setting the equation to 0 to find our x-intercept. And to do that, we need to add 4 plus 1 over x plus 3 equals 0. But we need like terms. So we're going to change the 4 into 4x plus 12 over x plus 3. And then add 1 plus x plus 3. Or 1 over x plus 3. And then it'll turn it into 4x plus 13 over x plus 3. And then since it's 0, multiply x plus 3 over to 0, you'll end up with 4x plus 13, which will lead to our x-intercept at -13 over 4. And then we're going to find the solutions between -13 over 4 and our asymptote -3. So over here we have a number line, and we're going to have two circles at -3 and -13 over 4. And then since our curve is on -3 over 4, we're going to have that closed. But since -3 is our asymptote, we're going to leave that open. And then since we're finding everything in between, we'll shade our number line in between our two circles. So our solution is -13 over 4 is less than or equal to x, which is less than -3.